This conference will now be recorded.
So we'll start shortly. You can go through. So you install these two packages, TTR and Focus. Install these two packages. I just typed in the common window. Try installing that too. Let's wait for 2-3 minutes. We'll start at 14:07. Whoever didn't install TTR and Focus package, please do install TTR and Focus. Is my screen visible to everyone?
Yes, sir.
Okay. Okay. Thank you. Yeah, let's start then. So these two packages, I'm assuming everybody already installed these two packages, TTR and Focus. Okay. So now, where we were yesterday, I'll start from that piece. So we have time series data. We are representing that using YT, and this is T, right? T versus YT. T is your first time point. This is your second time point. This is your, and this is your kth time point. Okay. and this is y1, first time point value, which is the time series actually. That might be sales, that might be GDP, whatever you want. Y3, YK, and so on. Tn up to nth time point, yn. That's it. So this is your T versus Yt. So anything we are symbolizing as T versus Yt will be a time series. This is equivalent to a time series. Okay. Yeah. Now T Yt. So T1, T2, Tn, Y1, Y2, Yn. This time series data Tyt. So this will be we are using to create future forecast, future prediction, right? As we were discussing. So for future prediction, this will be the input. This will be the input. This will be the input in the model. In the model, and we will get some forecast. Forecast, right? And we need to see whether these forecasts are workable or not. Forecasts are good or not. So I'm rephrasing this part. I'm just saying measuring model performance. Measuring the model performance. Model performance. Okay. So these are our steps. Let's formalize this little bit. Let's formalize this little bit. So far no question. Let's formalize this little bit. So we are talking about time series forecasting model. Okay. The first step, analyze the data. Analyze. So first step obviously to load the data. First step. So let's load the data. So this is very obvious. That's why we may ignore that. I am saying that this is step 0. Then step 1, analyze. And act accordingly. Okay, analyze and act accordingly. If there are some missing data, we need to impute. If there are some outlier, we need to impute. If there are some other anomaly, we need to impute, right? If there is some data type issue, we need to resolve that. These kind of things, right? So analyze and act accordingly. That's why I'm saying. So I'm refreshing this as exploratory data analysis as well. Exploratory data analysis. Famously, famously known as EDA, right? EDA. Okay. From this exploratory data analysis, what we are getting, we will be getting a ready data for model. For model. Okay. Ready data for model. Everything, step 0, step 1, step 2, we are doing in a software, right? It's a software. R, that may be Python, that may be Spark, whatever. Software. Software. All the steps we are doing, performing, right? Ready data, we get the ready data of model. Then what we are doing? We are doing training is to test split. That may be 80-20. That may be 75-25. That may be 90:10. Depends on the data volume and all that. Okay, there is nothing fixed. So far we are going to consider 80-20. 80 is not too high and 20 is not too low. That's why. Okay, so we will be using 80:20. Okay, now step 3. Step 3. Step 3. What will be the step 3? Training data. Training data to model. Model. And model is for us, model is a black box. We will understand the algorithm definitely, but model is a black box for us. That's why I am just, so we don't need to do anything to do the model. We can just provide the hyperparameters and execute the model in R, and the model will be ready, the model object. Okay, using the model. Then step 4. What is the step 4 then? Step 4 will be output the model object. Model object. Using that model object, we are going to generate forecast for the test period. Test period. In time series test period, in regression problem, that will be test data. Test period means first 80% of the time point, the data for first 80% we have already used for modeling. Rest 20% for rest 20% of the period. At the last, we are going to generate the forecast, right? That is automatically, this is my step 4. Okay. So any doubt till this point in terms of methodology understanding? Let me know. Okay, I am giving you 1 minute, 2 minutes. Already there is a question. Can you please repeat EDA, like missing data and what else? Okay, sure, Nivedita. Any other question? You can go ahead. And EDA. Okay, EDA. There might be many things. Primarily common sense driven, Nivedita. Primarily common sense driven. What we can. So in EDA we may face missing value, outlier treatment, any transformation we might require, like log transformation, and many more things to go for time series. Many more things we will discuss in detail in the next class. Things when we learn stationarity and non-stationarity, we will discuss that. Okay, Missing value, outlier treatment. So far for you, the answer is this, and there will be there might be some transformation we need to do to manage the time series properly. Okay. Any other question? When do you choose cross validation data? Okay, Rupam, I am coming to that cross validation. I am coming to that after the model. So I will take this question at the end. Okay, because that will be relevant at the end. Cross validation I will explain. Okay, just keep that in mind, because if I answer this now, then that will not be relevant for this. Cross validation means multiple time validation. In before higher secondary, we appear for pre-test, after test, then we go for the final, right? That is also performance testing of our knowledge, our training for preparation of HS, right? So some kind of, if multiple time you are testing, that is called cross validation, and there are some techniques for cross validation in time series. How that will be applicable, I'll explain. Okay, sir, what do you what to do with outlier? Should we remove them? No, Preeti. We can impute them. If the outlier is a significant portion, then we may impute them, or in some of the cases we should keep that. Outlier is a real thing, then we should keep that. Whenever we are dealing with an age data, if age is getting -1, then we should impute that. If the age is getting 150, then we should impute that. But in case of salary, if someone is getting 1.5 crore per month, that is possible, right? That's an anomaly. We should keep that in the data. We need to analyze based on the reality. So if outlier is actual, real, then we should keep that, because that will train our model. If outlier is not real, it's by mistake, by data collection mistake, then we should impute that. We need to understand that. We need to mature our analysis thought process according to that. That's a very subjective question. Depends on you when you will be analyzing the data. What should you do with the outliers? Too many outliers can reduce model accuracy. Model accuracy is not the only thing, Preeti. Model accuracy. We need the real thing as well. Okay, model accuracy is not the only thing. So so too many outliers cannot reduce, in some of the cases too many outliers cannot reduce model accuracy, because outliers might be real, might be correct thing as well. Like outliers might be correct thing as well. So the correct thing, if you replacing correct thing by wrong one, anyways you are losing some information. So I'm showing you shortly. So till now, I'm hoping everyone is clear. I'm answering to this question in the next page. Okay, let's move on. I should save this. Reduce until not. Suppose this is a data. Yeah, I'm plotting a data against time. It's a time, and it is your YT. In a particular data, this is your data, right? So you can see this is outlier, and this is also, this is you can see this is outlier, and this is also an outlier portion. It might be, there might be the cases where these outliers are real values, real scenario. Then we should, then after imputation, it will be looking like this, right? It will be exact for the rest of the part. So see, in this case, and in this case, you are losing some information. The real cases are this, right? So you need to judge that whether these are real cases or these are mistyped by someone during data collection. Okay. So, and in some of the cases, in some of the problems, also real cases we might need to ignore. We need to include outliers. That is also very subjective in nature. So it depends on your problem at hand. Yeah. Suppose after 5 years, 5 years to 5 years, 5 years, you are going to predict the general card sales after 5 years. Now this is 2020, right? This is 2020, 2020, 2019, and 2018. 2018, and suppose in 2025, just you are just predicting the card sales. You are just predicting card sales of 2025, April, May, June, this quarter, card sales, right? So for that, then 2020, I think 2020, by 2025 everything will be normal, back to normal. So we don't need 2020 data, because now if you see the card sales in so I'm just plotting the card sales of 2018 and 2019. So this is 2019, 2018, and this is 2019. So this is the card sales, and now in 2020 the card sales should be here, right? In 2021 that might be here, that might be here, that might be here. So, and if you go back, this should be the card. So this is a sudden drop, right, for this coronavirus situation. It might be the case in 2025 when you are predicting your model, 2020 data is not needed anymore, it's an outlier. Then you can impute this, then. Sorry. You can impute this. This is the case after imputation. This is the case after imputation. Sorry, this is not that. This will be same. For the rest part, it will be same. Okay, so you see, so I just remove this outlier. And in some of the problems, you might need this data, because this is a real scenario, right? You might need this data. So in 2025, if there is another pandemic at the doorstep, hopefully not, but I'm just saying for example, another pandemic at your doorstep, then to predict current card sales, you need this data, you need this information. So that's the thing. That's why I'm saying it's very subjective in nature. Okay, outliers like Ambani Group has effect on Indian economy distribution. The outlet info is important. Outliers can be removed. Discussed post discussion the subject matter. Yeah, sorry, discuss post discussion with subject matter expert. Yes, Tarundeep. Okay, to its subjective and real scenario. Okay, hopefully the doubt is more or less clear. So let's move into the subject matter then. Okay. Uh, now performance testing. So the last step I will be discussing a little bit. Performance testing. Performance testing. Performance testing. This is the part I am going to discuss a little bit. So after doing the model, so what is the step number? I just forgot. What is the step number of performance testing? The last one. Can you please remind me? Oh, 4. Number 4. Okay. Number 4, performance testing. So these performance testing, what you are getting, T, YT, and this is your model output FT, forecast, right? Forecast. This is your forecast. So T1, T2, T3, Tn, and this is Y1, Y2, Y3, Yn, and this is your FT, F1 forecast. This is model forecast. Now I'm calculating the error et y1 minus f1, y2 minus f2, and so on, yn minus fn. Okay, so what is the problem in this simple simple minus? So that's my question was. Anybody have the answer? Okay, generate fc. So any problem in this? If we are taking simple minus, total error may come to 0. Correct. Correct. Positives and negative might cancel out. Correct. Correct. That's the answer. Preeti. Nice. Nice problem, Preeti. Okay, we should take mod, or we should make this positive anyways. Right, Rupam? Okay. So I'm little bit explaining this. Suppose I'm taking one small example. This is T, YT, FT. So T I'm not in YT, suppose it is 4 and forecast is 2. Forecast is 2 and the error is 2, and now the YT is 2 and the forecast is 4 and error is minus 2. 3, forecast is 3.1 and error is minus 0.1. Okay, so if you can see, if we are adding this to take average, this error and this error is getting cancelled out, and 0.1 minus 0.1 is only remaining at our hand, right? But this is not the actual case, so we need to make sure that these errors are absolute. So we can take modulus, or we can take square. Anyone we can take, right? Among this, so you can see, based on that, several model performance measures has been in the process. These are the several Samani measures technique you can see in the. So first one is the mean error. Mean error means just average of the mean. So we cannot use that because positive negative are getting cancelled out. Then mean absolute error. Mean absolute error is just absolute value of the mean. We can use this, right? But this is unit. There is an unit. There is an unit, right? In mean square error also, it's squaring the error. Again, there is an unit. There is an unit dependency. Root mean square error. Here there is always this is another case where there is an unit, usage of unit. It's not unit free. Mean percentage error, again we need to make this absolute, and finally we can have this mean absolute percentage error. This is called MAP. MAP is mostly used because this is relative. We are dividing that with the original value as well after calculating the modulus of error. After that we are taking the average. This is called MAP, mean absolute percentage error. Okay, so we'll go with this MAP, and just you can see the slide and let me know if you have any doubt. You can just read through, very easy thing. Okay, let me know if you have any question. Okay, fine, hopefully there is no question. So enough of theory. Now let's move on little bit into the steps. Yeah, so you can open this code number 3, stationary T and modeling. Code number 3. Okay, so first First, what you need to do, just open R and get ready with this code. I'm waiting for you for 1 minute. Very important. We need to go together.
Sir, where is this file?
Okay, I sent this today to Sagoto. Hopefully, it will be available in Canvas. Anybody have that file? If not, let me know. We need to upload.
Yes, sir.
Okay. If you have any group email or can you send that to Madhusmita in your group email or something like that? If it's in Canvas, please download that. I'm waiting. Don't worry.
Yes,
One.
got it.
It
I
is
just to refresh
it
the
is
page.
available in
I
the
got it.
canvas, sir.
Okay. Okay. Perfect.
Yes, I had to refresh the site. It's
Yeah. Yeah. Yeah.
available.
Go ahead. It is Tarun, right?
No, sir, I was Rupam.
Rupam. Sorry.
Yes.
Yeah. So you need to run these two lines, TTR and forecast. After that, set properly the directory. Okay, your working directory where the code is hosted, where the data is. The yesterday data should be here. The same data sheet. Time series delta underscore 7.2916. Okay, Oman employment data one. After that, my vector, the my TS plot. Let's plot this. You can see the plot like yesterday, the same thing, nothing new till now. Okay. After that, so this is step 0 and step 1. Step 0 is done. Loading the data, right? And though it's a very regular data, we don't need to do any exploratory data analysis on and all, because exploratory data analysis includes this plotting and stationarity check and all those things. So we'll be explaining a little bit in the next class. And missing value is there is no missing value actually in this data set, right? You can remember that yesterday, remember that from yesterday's discussion, there was no missing value. So we are going ahead with that. We are just skipping, not actually skipping. We have already plotted this. So this is step 1. You can see for this. Nothing else is required in step 1. And step 2 is, I guess, splitting, training, and test. Right? Am I right? Let me know, please. What was the step number 3? You are getting cannot change the working directory. So you just so wherever this code is, just place there. Wherever the code is, just copy that directory. Wherever the code is, the copy that directory and run this command. Copy that, and you need to reverse this one. In session set working directory. Yes. Okay. Thank you, Rupam. In some of the cases, I am unable to see this chat every time. Please help. Thank you. So you can copy this code in the session. You can run here after opening the R. You can run here. Okay, thank you. Now, now step 0 and step 1 is done for us, right? Now training and test split. Training and test split we need to do. First of all, I'm changing the code little bit. Don't get confused. Just I'm saying. So what is the total amount of data? So what we are going to do? So what you are going to do? We are going to do so total number of suppose there is 400 is the total number of data. Then 400 into 80%. This will be my data in training, and 400 and last 20% rest. The rest will be in test, right? Then we need to find out size, data size, or data size first. Size, data size, n row, number of row in the original data. TS data is my original data. Done. So let me show you that data size. Data size you can see 629, and you can also print that here 629. Then for top 80% of the rows we need to take in the training data set, right? So data size, so training size, write with me. Data size into 0.8. Training size 503 into 2. So this is a fraction, right? There is a decimal. So we need to round that. We need to round. Just put round the training size 503. Okay. Now training data. I am just, we should have this training size, because 503 will not be always your training size, right? Training size, and your test data size will be test data partition will be your training size plus 1 up to end. Up to end. Training size, not training size, sorry, data size. Data size. Whatever you can see in my screen, these are the 4 lines I have added. Just do that at your end as well, and let me know if you face any challenge in understanding. Okay, let me show you training data. This is the training data. This is the training data, and this is the test data. You see, test data is starting from, this is a row index, is it's keeping the row index as well, 504. It's starting from 504, and this is starting from 1. The training data is starting from 1, and it's going up to 503. And again, test data is a rest. Test data is coming starting from 504 and ending at 50629. The end 629 data point we had, right? These 4 lines I have added. Let me know if you have any problem. Let me know. Nivedita, Rupam, Madhusmita, yes sir. Okay. Anybody is spelling any, which is used in what situation? Funny your question. I didn't see that. Which is used in which situation? Which model you are saying, right? Okay, I'll take your question at the end. Funny. Done, Tarundeep, done. Okay. Quickly do, I'm waiting for 1 minute. Let me know quickly. Can you explain why this? Okay, Tarundeep, you was in the last class or you missed the first part? The time series object it is creating. Okay, time series object it is creating the starting time point. So though it's a monthly data, that's why the frequency is 12. Right? It's a monthly data. The frequency is 12, and the starting time point. This is the starting time point, and this is the ending time point. You might not do this in this case because we are anyways splitting that another time. We may ignore this 10 and 11. You may ignore. Data size 8, 0.8 not found. Data size star into place and place this one. Take this. Tarandeep, you got my answer? Okay. Is it execute? Let me know, Nivedita and Tarundeep, Madhusmita, everybody. No problem, I guess. Okay. Okay, I'm going ahead then. So now we have training data and test data. So we are done with test number 3, right? Number 3. Now again for training data and test data, these are simple data frames, right? We need to create time series object for those. For training and test, we need to. So just training and test, just comment these 2 lines out. Training and test you have already created. Now my vector training, this one, my vector test, this one. Just execute these 2 lines. Now training TS, I am creating training object. Now you need to find out that what is the first time point of training data and what is the last time point of training data, right? After that you can do that. So that's why we need to run these 2 things. So this training and test, this training, the first time point, how you can find out? First time point you can find out in this manner. First time point 1 1, first row, first column. This is the first time point. Okay, and last, what is the last time point? In row training. This is the last time point of training. Okay, similarly, what is the first time point for test? What is the last time point for test? Right, that's why 1164, that is 64.1. It's a monthly data, that's why frequency 12, and the last data point is 2005 11 November, that's why, and keeping this 12. And for test data, the starting point is 2005 12 up to 2005 11 November, it was training data, and from 2000, starting from 2005 December, is test data, and up to the end 2016 5 the frequency period. So training time series and test time series. That's how we can decide. Let me know if you have any doubt. Also, you can automate this. That will be one your homework. Automatically, I am seeing this syntax, and I'm putting this here, the time. So let me know if you are done this step. Let me know, please. Okay. You have to sort. If not, you have to sort, not assume. It's there. You have to sort that one. Good point raised. If not, you need to sort that. If not, you need to sort that. So that is part of step one. That is another thing we need to check. Equispaced, whether the data is equispaced and it's sorted. It's sorted. If there is any missing value, if there is any outlier, stationarity, and all. Okay. Then the homework will be just note down the homework will be, I am just seeing this training 1 and training this dates, first date and last date. I am seeing it manually and putting the date over here, right? You need to do that automatically from the code. That's the homework. Just note it down. You need to do that automatically. I am giving you one clue. Use GREGEXPR. There is a function GREGXPR. Just note that down. Okay. Now we are done with step 2. 0 1 2 is done. Now yes, now the model step, right? Step number 3, the model step. So model step was black box anyway, but before going into that, we need to know what model we are doing, at least the basic calculation. So anyways, the things are black box, I understand, but some calculations are in between, right? So we can learn that basic calculations at least, right? So model, today we will be learning 3 forecasting methods. First one is moving average, second one is weighted moving average, and third one is simple exponential smoothing. Simple exponential smoothing. Okay. forecasting models. Now, simple moving average. Simple moving average is this one. So you are just taking average of past periods. Simple average of the past period to get the forecast. Suppose you have TYT 1, T1, this is T1, T2, T3, T4, and your YT is 100, 101, 102, 103. Okay. Now simple moving average means, so FT of period 2, FT with period 2 I am calculating. For this one, the average will be with this of period 2, 101, 100 plus 101 by 2. For this one, this plus this by 2, 101 plus 102 by 2. For the next point, this will be 103 plus 102 by 2, and so on. Okay, if you need. So obviously after that you will be getting some error because you are going to do that forecasting based on forecast, right? So this is simple moving average of period 2. If it is period 3, then we cannot calculate for this. If it is period 3, we cannot calculate for this. We have to start from here. So we need to take past 3 values plus 100 as well. We need to divide that by 3. Here also we need to take past 3 values. 103, 102 plus 101 by 3. Past 3 values, right? So see, this is simple moving average of order n. So dt minus 1 up to nth value, up to past n value it is going on, and to create the forecast. This is a simple moving average formula. Let me know if you have any question on this. What will be the forecast of period 6? Period 6 will be, if you are calculating, okay, period 5 for that example, right? Period 5 will be, if it is period 2, assume the same to period 5. Yes, period 5 will be, if it is for period okay, period 6 you are asking. Okay, sorry. Repetition period 5 or repetition period 6 or period length 6, you cannot calculate because the data is not available. Okay, so up to period 4 you can calculate over here. Usually 4 data, we think with 4 data point we don't go for forecasting. Usually it's an example, I cannot write more than that, that's why. So it's for period 6. If you want to do, you need to get more data. The formula will be same. Okay, Bipin? Okay, fine. So I'm just keeping this simple so that you can remember. After that you will get more advanced questions. When you apply, you will face some problems, then you will get to know slowly by yourself. Okay, so this is moving average. Why moving average? The average is moving clearly, right? Average is moving. Why moving average? Now the question is why moving average, right? So it's a common question. It came to my mind when I learned this first time. So I'll explain that to you as well. Why this is moving average? 1, 2, 3, 4, 5, 6, 7, 8. T versus YT. These are the values. So for period 3 will be this. Period 3 will be, we are taking these two, right? For period 4 we'll be taking these two, 2 and 3. For period 5 we'll be taking these two. Anyways, these moving averages are moving towards the end, right? That's why it's moving average. Moving average. That's it. Okay. Now simple moving average is done. Now weighted. Weighted moving average. The same thing. TYT. 1, 2, 3, 4, 5, 6, 7. Y7. Okay. Now, so moving average of period 2 is Y1 plus Y2 by 2. Here it will be Y3 plus Y2 by 2 and so on, right? So weighted moving average, this will be not a simple average. Weighted moving, this is simple moving average. The weighted moving average is, so if you think that the recent most period for a forecast, so what is the recent most period for period 7? Which period is the recent most period of for period 7? Let me know. What is the recent most period 6? Correct. What is the recent most period for period 5? Period 4? Correct. Recent most period. So you need to provide more weightage to recent most period. So this is very subjective in nature. Recent most period. For period 3, period 2 is the recent most. So you want to give double weightage to period 2. So weight will be Y1 plus 2 into Y2 divided by 1 plus 2. That will be your formula. So for period 4, Y3 will be the recent most. So 1 into Y2 plus 2 into Y3 divided by 1 plus 2. So given a weight to the observations, maybe more observation to the recent one, you might be also looking for more observation in the far one as well, case by case, right? So that is called weighted moving average. That's it. Very simple as well. Simple moving average with some weight. You see, you have the formula over here. W1 plus W2, these are weights. Weights they are expressing in this formula. How they are expressing the weight? The weight from this equation. Weight from this equation they are expressing in this manner: 1 by 1 plus 2 and 2 by 1 plus 2. So it's subtracting by the weight actually. Okay. This is W1, this is W2. You can see the formula over here in this slide. Let me know regarding any question in weighted moving average. Yes, 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 Pritham. Why not 2 into y2 plus 3 into y3 2 plus 3? So you are asking about 2 into y3. So Pritham, just it's not clear. So see, you can choose your own weight anytime. Hello? You can choose your own weight, Pritham. Summation of the weight, always you can make it 1, always. Yes, always you can make it 1. You are taking 5, 6 and 7 as your weight, and the weight will be eventually you need to take 5 by 5 plus 6 plus 7, and 6 by 6 plus 5 plus 6 plus 7, 7 by 6, 5 plus 6 plus 7. Anyways, it will be boiled down to 1, right? Because your numerator will be the sum of the weight. Fine? Okay. Perfect. That is weighted moving average. Now let's proceed with these two. After that, we will discuss exponentially weighted moving average. Okay. So now, so training and prediction. Training and prediction. Usually, you see in the, you saw in linear regression, in decision tree, in logistic regression, you saw that one piece of our code is creating the model, and another piece of our code is predicting for the test data. But the nice thing is, in simple moving average and weighted moving average and exponential moving average, we learn that later in this class. So we need only one line of code to do this. Model plus prediction. That's it. Okay. So you see, this is the line. This is the syntax. SMA training n equal to 2. N equal to 2. What is n? N means number of periods. So 2, 3, I give you the example. Now here it's 2. You can make it 3 as well. And h equal to 10 means how many data points forecast you need out of this. So future 10 points forecast it will be giving you 10 points forecast. Or you can make it 100 as well. It will give you 100 points forecast. Okay. So I'm just executing this SMA forecasted. Sorry, it's not executing because I might need to run these two lines. Simple moving average, it will take time. You can execute this line SMA forecasted. It will take little time because the data is not small. Okay. Eventually we'll end up with some warnings. You can ignore those warnings because some we have encountered missing value. There is no missing value. So this warning is not real. And allow multiplicative. Some in ETS there are some warning as well in convergence warning. You may ignore that as well. No, don't need to worry. So SMA forecasted. After that WMA forecasted. And what is WMA forecasted? The period is 3, right? For period is 3, you need to provide 3 weights. Or if the period was 4, you need to provide 4 weights as well. Okay, and you can put the weight using the syntax C vector. So 1, 2, 3. You can also mention like this 1, 2, and 3. Let's make that C 1, 2, 3. Excuse me. I'm executing this weighted moving average line. So again, we are done with the forecasting. And EMA forecast is exponential moving average. We'll learn that later, so I am commenting that out for now. Okay. So again, EMA forecasted, I am again commenting that out. I am just ignoring that now for now. So SMA forecasted. So this is the forecast for SMA forecasted and WMA. Okay, the forecast result is this. The first column is forecast result, second column is 80% lower confidence interval, upper one is 80% higher confidence interval. This is lower 95, higher 95. So in sometimes in some of the business cases needs one range for, instead of one particular forecast they might need one range. So this is the range. So L080 and A8080, these are 80% confidence interval. With 80% confidence we can say that the forecast will be lying within this data point. The first forecast for 2005 will be lying between 53341.55 and 53520.48. Okay, lower confidence interval or 80% confidence, and for 90% more confidence if you need, you are more sure. So see, it will be a little bit wider as well. So 95% confidence interval will be 53294 and 53537 for the first data point in simple moving average. Okay, so instead of this you can type only one and make it and create and enter, so that you will not get confused. Just see in this manner and let me know whatever question you have. SMA forecasted, 10-point forecasted, you can just see. So our training data was up to December and up to November 2005, right? The forecast we claimed for 10 periods next. So you can count, there are 10 data points from December 2005 to September 2006. There are 10 data points. For 10 data points we have 10 forecasts. Just look into the forecast figures and let me know if you have any doubts. I'm waiting. It's important to understand. Arun could not find the function. So you have the package forecast, Arun? Just this package is needed, Arun. Just install that for forecast. SMA training n equal to 2, could not find SMA. So you executed this line, forecast and TTR? I don't think so. Nivedita, just try that out. These two lines we need to execute. We need to load the library. Weight, okay, you want to provide this weight? Yeah, you can provide in C, in vectorized format. In this format, Madhusmita.
Yes, sir.
In this format. See, you want to provide these three weights, right? 0.5, 0.4, 0.1.
Yes, sir. No, 4 I got, sir. Not 3. I have 10.
Okay. Okay, you got the answer that, right, Madhusmita?
Sir, I got the answer.
Okay. How I understand this forecast data? Yes, funny. I'll explain another time. But still getting error. In which line, Nivedita? Let me show you. Show me. Ping me the error here. Could not find the function forecast. So Arun, you got that? Let me know. This line, weight this by 10. Okay, okay. So if it is running, that's fine. Madhusmita. Not yet after running the library. Okay, after running the library, you loaded the library, the forecast and TTR?
Without
Okay.
running.
Okay, this line you are getting error, right? SMA forecasted. Arun Nivedita. Okay, you solved it. Fine. This line, right, Arun? So make sure that you have this input, training TS as well. Arun, ping me the error. Okay, it's running. Okay, sure.
Sir, it's running. After showing the error also, the next phase it is running. Once we asking for the viewing, it is running.
Let me check with Sanjayita. You are not replying. Is it running at your end? Siddharth, Sonali, Sumit. Bindu. Okay, SMA forecasted forecast. Yeah, this is not error. This is warning, Arun. It's already executed. It's not error. Warning. It's not error. It's the internal error for ETS. There might be some update issue. I am also getting that. Don't worry, there is no missing value in the data. It's fine. Okay then. Now to answer funny. Sanjayita, problem with library sir, reinstalling slow net. Okay, Sanjayita. Do it. It will eventually you can execute this easily. Not a problem. Should not be a problem. Lokesh, yes, running. Work for me, everyone. Okay, fine. Then let's move on. So now this is SMA forecasted. SMA forecasted to answer you funny and all. SMA forecasted. This is a tabular structure, right? The first column, first two columns, you can see the time point. Okay, the number of row will match with the H. H equal to test size. Why this is test size? Okay, H equal to 10. So here I provided test size. Don't worry. So H equal to 10 I have provided, right? H equal to 10. So there will be 10 rows here. 10 rows, 10 forecast. So first one is point forecast. Point forecast means, what is point forecast? Point forecast means I am claiming that the exact woman employment number in December 2005 with using simple moving average will be 53,431.02. 0.02 you can ignore anyways. 53,431, right? And with 80% confidence I am saying that it will be, so then the third column will be point forecast. This is the exact forecast I am claiming by the model SMA, and the L080 and HI80, this column is saying together that with 80% confidence I can say that December 2005 woman empowerment will be lying in between 53,341 and 53,520. Okay, and the last two columns L095 and HI95 will be saying the same with 95% confidence. It will be lying between 53294 and 53567. That's it. The same for every row. Same thing for every row. These are interval estimations, confidence intervals. These are called confidence intervals in forecasting. This is point forecast. These are called confidence intervals. Okay, great. Get now. This is WMA forecasted. This is SMA forecasted. Now actually this is just for illustration to you. So how many data set we need the forecast for? The test size, right? For the entire test period we need that. So row number, we are calculating the row number for entire test size. We are getting the row number, and then we are getting the row number for entire test size. We are executing this, and SMA forecasted we need to rerun using this H equal to test size. Okay, EMA I am not executing now, so I am just putting that in comment. SMA forecasted, WMA forecasted, EMA forecasted. Again it is executing. It will take time. Again the same warning will be there. Don't worry about that. Until analysis is not error, we don't need to bother for now because we don't have any missing value. That might be some update issue. For that it's showing some error. Now let's plot. You see the plot. See the plot. The blue, the turquoise, rather. Turquoise is the forecast, point forecast. The gray one is the interval, right? This is the 80% interval. And the light gray one outside that, the outer band is, what is that? 90% 90% confidence interval. This is the forecast. And forecast is not bad. See, you remember the original one? Forecast is not that bad. Okay. Now what we need to do, we are done with the step number 3. We are done with the step number 3. Now we need to measure the performance. That is our step number 4, right? So 95%. What is 95% funny? Is this the accuracy you are saying? Okay. Okay, so it's 95% confidence interval you are saying. So 95% confidence interval and accuracy 95%, it's not the same thing. Okay, just I'm mentioning. Now what is this? Now accuracy we need to find out accuracy metrics. So first what we are doing, we are doing SMA DF, WMA DF. We are calculating, we are creating data frames using these forecast figures. SMA DF and WMA DF, we are creating forecast figures. Okay, this is SMA data frame. And WMA data frame, where is the WMA data frame? WMA data frame. Perfect. Now accuracy. For accuracy, we need to find out the forecast, our F. This F, what we are looking for, the forecast. TYT F is our time series model output, right? TYT versus F. TYT FT. This is the time series with forecast, right? So now we are storing the F over here in this data frame, and if needed, you may download that as well using this write.csv and all. I have already written that write.csv. I'm not generating that over here. So after that, we are just taking the forecast that we are adding in this test data. Test data you already have. You remember we have created one test data. I'm just doing a view test data. View test. This was my test data. In this test data, I am appending the forecast. I'm creating a new column and appending that forecast value, point forecast. Remember? So this is the step. I'm doing this. It's forecast. Now see, test forecast is here. Forecast simple moving average, forecast weighted moving average is here. Now let's see. Now we need to calculate the mean absolute percentage error for performance, right? What is mean absolute percentage error? This is the mean absolute percentage error. This one I am highlighting. Okay, and calculate mean absolute percentage error and ping me the accuracy in private. Everyone, calculate the mean absolute percentage error and ping me the accuracy in private window. Okay, everyone. Okay, Madhusmita, you are using some package, right? Different package. So first, without using package, do that. Try doing that.
Sir,
The
error
calculation
has
will
been
be
generated.
okay. Some errors you are getting. Which one? Here. Let me know what is the error.
Line number 84. It is saying, just a minute, that object SMA underscore DF is not found actually.
Okay, so you need to create that then. Simple answer.
Okay, sir. Okay, okay.
Find that out where it is getting created.
Okay.
Please answer in private. So you need to mention SMA. What is the accuracy of SMA? What is the accuracy of WNA? You need to mention that as well. Tarandeep Rupam. All are one. All are one means funny. You need to recheck. Cannot be. Okay. I didn't get thing ordinum 97%, 97%. Yes, Lokesh. Devojyoti, Bindu, reply please. Sonali, reply. Sumit, reply please. Nivedita, reply please. If facing any problem, let me know. Okay, so the question is you need to execute this forecast. So you need to find out this forecast. So you need to just calculate the accuracy. Accuracy code is there, right? Just calculate the accuracy for SMA and WMA. It's simple MAP, mean absolute percentage error. If you can see this formula MAP formula over here in the PPT, and you can see the same formula is written here in R in line number 88, 89 in my screen. After getting this MAP, mean absolute percentage error, you have to subtract that from 1 and make it percentage. Then you will get the accuracy. So this line, these two lines, after executing 89 and 88, 89 in my screen, and then after executing 92 and 93, you will be getting two accuracy, for one for SMA, one for WMA, and you need to just report back to me. Okay, need time getting error. What kind of error, Madhusmita? Let me know. Error in data frame TMP WMA value 53 replacement have 10 rows. Data. Okay. So you need to execute this. So in the lower block in the code, you can see. So initially for illustration, I did this for only 10 points. After that, I did that for test size. What is the test size? First, it was for test size. First, it was for 10. After that, it was for 126 data points in test set. So you need to execute this piece of codes. After that, you will stop getting that error. Okay.
Okay, sir.
This for Arun, I answered. This is important. Let us know. This is the final step of our model. Explain the diverging region. I could not attend that part. Diverging region in the plot. Okay, Bipin, I will answer your one question and another cross validation one at the end of the class. Funny. Okay, so you already calculate for EMA as well, exponential moving average. That's easy one. Okay, fine. Okay, perfect, Nivedita. Okay. Any answer went unanswered? Let me know. Except Bipin and that cross validation one. Let me know. Need time getting error. EMA 9. EMA I don't need now. Okay, so only SMA and WMA will suffice. Okay, perfect. So let me execute what you are doing. Just see my screen from the top. See, so this is my model, right? So now initially I did it for 10 data points to illustrate you guys, right? After here, see there is a comment putting h equal to test set size. So I need to, so till November 2011 I have the training data, and starting from that till 2016 May we have the test data. That there are 126 data points, right? For 126 data points we need to create the forecast to do the proper testing. So I am just finding out, so test set size, this is the test set size. What is the test set size? That is 126. Then instead of h we need to, instead of h equal to 10 we need to put h equal to test size or h equal to directly hard coded 126. I'm just putting that. Now I am running the forecasting model. Then I'm running again the forecasting model for WMA. Let it get executed. I'm getting one warning. No, not error. You don't need to worry about that then, because we don't have any missing value, though it's saying it's missing value encounter, but we know that there is no missing value. You can check in the data point as well. Always we cannot believe the softwares. Now to answer you, Bipin, so SMA forecasted. What is SMA forecasted? SMA forecasted is, it's a 4 column. First column is the time. First two columns are the time. Third column is the point forecast. Fourth and fifth column are 80% confidence interval. That is, these two values are saying that our forecast will be, the value will be lying within this range, lower and upper, with 80% confidence. Same for 90%, 95% confidence. This 95% confidence interval, a lower limit and upper limit, and this is 80% confidence interval. So again, now I am plotting this. I am plotting this here. This plot, the blue line. So up to the black line is the real value, the actual test training data set. After that, the test data set is starting. And in test data set, the dark gray area is the 80% confidence interval. And 95% confidence interval will be more wider. You can see in the data, 90%, 95% confidence interval is always larger than, means wider than the, wider, not larger. The lower value will be low and higher value will be high, right? When we compare 95% versus 80% confidence interval, but that interval will be wider. The light gray area is the 95% confidence interval, and the deep gray area is the 80% confidence interval. This how we are doing the plot. After that, we are generating the plot for WMA as well. This weighted moving average, right? Seems like these are, the forecasts are not bad. Now we are creating data frame, SMADF and WMADF data frame. In this data frame, we have some columns. We have the column point forecast, having the forecast, right? So now with the test data set, we are appending this point forecast from SMADF. See, I am creating new columns in this test data set. I'm creating new column in this test data set, and SMADF, from SMADF I am taking the point forecast, and here I am taking the WMADF. I am also taking the point forecast. Now let me show you the data set. This forecast SMA and forecast WMA, right? Because why the name is like this? Because I have put the name forecast SMA, forecast WMA in dollar. It's a way to create new columns, in to add columns to existing data set, add new columns, or new columns, creating new columns. After that, we are creating the mean absolute percentage error of these two. Mean absolute percentage error of these two. Mean absolute percentage error means this one. This one, right? The formula mean absolute percentage error. After that, we are calculating the accuracy. Right? Okay. This is the mean absolute percentage error. Now accuracy of SMA is I am still getting error, right? Let me check this fast. forecast SMA. So I have to execute these lines as well. Now this I have executed. I forgot to execute. Now this one. 97.52 is the accuracy SMA, simple moving average. So, and for weighted moving average, it is 97.47. Okay, 97.47 is for WMA. Okay, now exponential moving average we will study, and let me know till this point anybody have any doubt. Okay, now exponential moving average. So exponential moving average is something like this. So is that in the PPT? No, I don't think it is added in the PPT. So let's discuss this. So you remember exponential series, E series? If anybody remember E series, let me know. Exponential series. Okay, anybody can give me one example of exponential function. Okay, yes, Pranavendra, good. Exponential function, any exponential function, give me an example. Sigmoid function, okay. Any other? Bacteria growth, okay, it's an example. Do you know y equal to e to the power x? Okay, y equal to e to the power. This is exponential. Okay, fine. So do you know normal distribution PMF? A PDF, not PMF, PDF. Do you know normal distribution PDF? Probability density function. One by root 2 pi e to the power minus half x minus mu by sigma whole square. That's an exponential function as well. Exponential family, that is. Okay, example is COVID-19 cases in India. That's right. Okay, let's discuss this formally. So exponential moving average. What is exponential moving average? So the assumption is, what is the assumption here? So y, so this is the most past. This is the far past. This is the past. This is the present. This is near past. This is the far past. Past, and this is recent past, and this is present, and this is definitely your future. Okay, this is your future. So now I can say to forecasting this immediate future, immediate next point, the most effective, so entire history I am going to use, but I will give the most weightage to the most recent one. After that I will give this data, this point, this past, a good weightage, but less than the less than this one, less than this one. Okay, so this will be getting most weightage, this will be getting less than that, 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 and so on, so on. It will, the weight will get decaying. So see, this is in revert looks like an exponential function, right? If you can revert, you will see that this is the simple y equal to e to the power of x function in revert manner. I'm just drawing that pictorial. That's it. Okay, so the weight will decrease if it is more past. As long as we are going past, going back, the weight will decrease exponentially. Weight will decrease exponential, but we will be considering each and every data point. That is called exponential smoothing, simple exponential smoothing. Okay, so simple exponential smoothing, let me write the formula for you. It's very simple. Y t plus 1, the forecast, that's why I'm keeping a cap over here, estimation, and t is my present, t is present, and t plus 1 is the next, t is present. This will be alpha into yt plus alpha into 1 minus alpha yt minus 1 plus alpha into 1 minus alpha yt minus 2 plus alpha into 1 minus alpha, sorry, square, this will be square, cube yt minus 3, so on, alpha into 1 minus alpha to the power k yt minus k, and so on, where alpha lies between 0 to 1. It's a fraction, so naturally 1 minus alpha will be another fraction. So as you know, alpha 1 minus alpha, if you put more power on 1 minus alpha or any fraction, it will automatically decrease. So anytime you can say the weight of yt minus 1 is greater than yt minus 2 but less than yt, any time point. Okay, that is the simple formula of simple exponential smoothing. And alpha, we need to find out the best alpha for your model. Okay, you need to find out the best alpha for your model, which is lying between 0 to 1. That's the optimization part you need to do. Okay, so this is the simple formula. So here I will give you one example of simple move. So some handcrafted calculation I will show you. That's it. Okay, now y1 equal to 1, y2 equal to 1.2, y3 equal to 1.4. So this is the data we have, first time point, second time point, and third time point. Then y4, the forecast will be, if my alpha equal to 0.8, the according to the formula we will have 0.8 into most recent one, that is 1.4 plus 0.8 into 0.2 into y2, that is 1.2 plus 0.8 into 0.2 whole square into 1. That's it. This is my exponential formula focus. Okay, then execute. Let us execute that one as well quickly. The exponential one as well. So just uncomment this part. That's it. We already executed. Funny already executed, I guess. If you already executed, then fine. Let's just uncomment that. Uncomment exponential moving average first with 10. I can show you with 10 for just for illustration. So here I have taken 2 by 3, 0.66 as your alpha. How to choose alpha? Yes, Devajyoti, we need to find out. We need to find out based on MAP. So I will discuss that. How to choose weight also, that is another question. How to choose period, that is also another question. I'll address those questions at the end. Okay. EMA executed. EMA, I'm running the EMA part only now. Accuracy EMA. Now let me know which one is the best for this data. EMA, WMA and SMA. Reply me in private. Okay, why SMA and why EMA? SMA for more accuracy. Okay, really this small accuracy doesn't matter. So I will, the three models it will be acceptable, any one of them. Okay, for the in this purpose. So let me tell you the broader picture behind this. Okay, how we can find out. So that will be one of your homework as well. Okay, so whatever I am just going to explain. So you can you write for loop in R? Can you write for loop in R? Who can't? Let me know. Who can't? For loop? Who can't write for loop? So everybody can write for loop. I'm assuming that. So NA. Arun, just create that. If you create this one, Arun. This one. I think so. Or not all the codes you have executed, Arun. So sir, just start from here and execute everything. So I think this one, this line you haven't executed. Test dollar forecast. You haven't added this forecast column, point forecast column in the data. Okay. So let me answer. So Arun, let me know after the class if you are unable to do this. I think you didn't executed this line only. Okay. So now let me move on. Now see very carefully one thing. Everybody can write for loop. I am assuming, though there was no answer. Now see, this is your homework as well. So we need this matrix. So for SMA, this table I need, this table. For SMA, I need this table period, 2, 3, 4, 5, 6, 7, 8, 9, 10, and accuracy. For 2 we already executed using for loop. We need the accuracy. This table for SMA. Okay. This table for SMA. For WMA, we need this. Period, period, 2, 2, 2. Now weights, W1, W2, W3. 1, 2, 3, 2, 3, 1, 3, 1, 2. Accuracy. If it's unclear to you, let me know. This accuracy I need. Then 3 3 3 again, same sort of weight will be repeating. 1 2 3 2 3 1 3 1 2 1 2 3 1 3 2. Okay, sorry. So there are more combinations, right? So for WMA, if you can understand what I am trying to say, so 2, there will be 6 combinations. 2 2 2. There will be 6 combinations. You understand? 1 2 3 2 3 1 3 1 2. Then 1 3 2. Then 2 1 3, and then 3 2 1. I need the accuracy over here. And for similarly for period 3, all 6 rows. All 6 rows. All 6 rows with the accuracy. Okay, I need this. And for exponential moving average, I need period, you may start from 3 as well. Period 3 4 5 up to 10, and you can start something like that. 0 0.6 0.6 up to 0.6. Then again period you can vary from 3 to 10 and 0.65 then 3 to 10, 0.7 is your alpha. This is alpha. This is period. This is alpha. 310, 0.8, and so on. Okay. 3 for loops I need. 1 for SMA, 1 for WMA, and 1 for exponential smoothing. Right. 3 for loops I need, and the structure will be something like that. And write it down in your copybook. Okay, if you face any difficulty, let me know. I will clearly write that this again. This will be your homework. So first copy this SMA and WMA, and then copy this exponential moving average as well. So after that, getting the accuracy, then we'll get to know which period for which period and for which weight, or which model is best, and for what will be the period and what will be the weights, or what will be the alpha, or if a simple moving average, period will be sufficient. So base model, we need to find out base model in this manner for any kind of data if we are using these techniques. Okay, we need 3 for loops for this. Let me know if you have any doubt. I can write it again 10 times. I can write, no problem. Okay, Arun is saying we'll try. Okay, how is the alpha decided in actual cases? Is it power of test? No. No. That's something else. That's for inference. That's for statistical inference. Level of significance. It's not alpha. Not that alpha. It's the weight, exponential decay weight. Yes, in value. N equal to 3, n equal to 2. So you can start from n equal to 3, n equal to 3, n equal to 4, up to n equal to 10. How it is decided? Yes, we need to decide based on accuracy. If we get highest accuracy for alpha equal to 0.88, then alpha equal to 0.88 we are our base model and exponential moving average. So 2 selection we need to do. First base model, and if base model is that, then what is the value of alpha? If base model is exponential, if base model is the weighted moving average, then what should be the weights, base weights? And if the base model is simple moving average, only period will be sufficient. That's it. Understood? Is the homework clear for everyone, or else I can write it down another
Yes,
time?
sir. So clear.
Okay, perfect. Gita, thank you. Okay, now let me quickly answer the cross validation one. Then, so cross validation one, so I think Rupam question that, right? The cross validation one, Rupam. So 80-20. So sometimes if we have enough data, sufficient data, first we do this for 60-40, for 60-40. Then after we do this for 65 for time series only. For normal problem, we can go for n-fold. So you already know that, I guess. If you don't know, I can explain in some other classes. But if you for time series, the cross
I don't know in
validation is
details.
hello.
I don't know in details. Okay, fold and
Yeah, cross validation. Cross validation means cross validation in any modeling technique. If we divide the entire data set in 10 parts, so first part will
okay.
be kept in test, and rest all the parts are taken for modeling. And after the creating the model, the rest part will get predicted by the other 9 parts combined. Then you can leave the second part and then combine all other parts, 1 3 all other parts. Then you can another time execute the model and test the second part. Then you can leave the third part only and combine the other anything, other all the parts. Then you can calculate the accuracy on part number 3 as well. In this manner cross validation works. But in time series, though, we need to keep the things in order. So that's why we do this at the end. Usual, if you want to do at all. So if we have sufficient data, then we do 60-40 first, we check the accuracy. After that we do 65-35, then we check the accuracy on 35%. After that we do 70-30, we check the accuracy. So every time if you are increasing the data points, the accuracy should increase little bit at least. It shouldn't go down, right?
Okay.
So that's the check for cross validation. Finally you can end up 90-10. So this all the folds you can do at the end.
Sir,
Okay,
for me, accuracy value is not coming. It is saying not available. I
which
tried.
one?
Oh, that SMA.
Accuracy. So accuracy value is not running, right? Just show me what is happening. Show me. Give me the error message.
It's not available.
It's not available. Just simply.
Yes.
So
Yes, sir.
I think someone else also got the same result. So I think you haven't added this forecast estimate. This line you haven't added. So you
Okay,
need to
sir.
have this forecast value in test data as well. After that you can calculate the
Okay, sir.
okay. I
Yes,
think
sir.
you need to add. So the code is available over there. Let's see.
Okay, sir.
Hmm.
Okay, sir.
So the homework is clear, right, for everyone. Okay, then I'll wait for 5 minutes. Then we can bring this to an end. Next week, I think we will continue time series. Continue time series. We might read stationarity, non-stationarity, some ARIMA, these kind of things we can go through. And please do this homework. Then you will enjoy more. Please share the test forecast codes. Test forecast codes. It's already there, Arun, in Canvas. This one, right, Arun? Please, please talk. Unmute and talk, please.
The error is coming. The test forecast code. Okay, I missed this.
Okay. Just show me the code. Show me the code then. Share. How can I make you presenter? Arun B, right? I'll show you. Oh, how can I make you presenter? Arun. So let's make presenter. Yeah. Show me.
Okay, one second. I missed these codes.
Yeah. Go up. Go to the top. Let's now just write view test. Escape. Put escape. Go to the console and put escape. Click on escape. Press escape. In the console, escape. Okay. Now view test. Capital V. Capital yeah. Test. Yeah, it's already was coming. Okay. Now go to the code. Go up. Okay, fine. Go down. Go down.
Sorry. I'm sorry, my
No problem. No
running
problem.
down.
ये में
I think I missed
just
this,
quickly run
test
estimate
point.
line number 80.
Line number 80. Okay.
Again run this. Okay. Now go down.
That's it. I don't have that. This
Oh,
code is
that's it for
missing.
your side. Okay. The rest part is missing for you, right? Okay, I'm
Yes,
just
sir.
pasting.
Just give me a second.
Yeah, I'm just pasting that part in the common window. I think that will work. Just copy paste and adjust the spaces in between and keep it. Pretty sure you can do that easily. Yeah, take it. Take it and log off then. No problem. Anyone else?
Sir, that screen got hanged, sir. We just can't see that.
My screen.
Yes, sir. I think your
No,
battery is.
actually Arun is sharing.
Okay, sir.
Okay, so I think you will be getting if that part is missing, just take that from the common share. Arun, you get that? Madhusmita, just do one favor. If Arun is unable to get that, please email Arun personally the code. Okay, Madhusmita.
Yes, sir.
Okay, so you are you able to execute that, right? You are not getting any anymore.
Yeah, sir. No, sir. I'm just doing now. I'm just whatever the codes you have written after test. I'm just writing. If it will be executed, then it is fine. Or else I'll ask from Arun Babu how he did.
Okay, no. Actually, no, that's not the case. Arun is also got stuck. Just try resolving at your end. You can send to Arun Babu.
Okay, sir.
So just copy paste the part if you don't have that part at the end.
Okay, sir.
So anyways, Nivedita, you have the updated code? I think she's speaking on mute.
No, I said yes in the chat box.
Okay, you said yes in chat box. Okay, just send it to Madhusmita and Arun Babu. Okay,
Okay.
if you are able to
Okay.
execute. Arun Babu and Madhusmita, just share offline your email ID to Nivedita. She will be sharing with you over email.
Okay, sir.
Okay.
I'm just sending her now itself.
Okay, perfect. Okay, Funny, could you please explain the period part? Yeah, period part is the how many periods we are taking into consideration when we are doing the average Funny. Okay, when we are doing average. If you have a time series of 10 periods or 10 or 15 periods, so for 16th period we are going to you are going to create the forecast. So how many period back you want to go? 5 period, 10 period, 6 period, 7 period, 3 period, 2 period. How many periods you want to go back? For at if you want to forecast 16 data point, 16 point, 15 or and 14 you are going to consider only the 2 period in the past, or 3 period 15 16 15 14 and 13, or 4 periods 15 14 13 and 12. That depends on the analyst, right? Whoever is dealing with the problem. So how much relevance in the past you think which is existing in your data, that depends on you. That is called period. That's an hyper parameter. You need to tune that as well. You need to find out the best period length as well. Okay, Funny. Sir, can we change default? No, we cannot. We cannot. For that, it's for this function, I think you cannot. Okay, there might be some functions. Just do one thing. Just try this function, SMA forecasted. The function is SMA forecasted, right? Just study little bit SMA. If there is any parameter within, you can change. I never use that actually. Study that function SMA and its parameter. You might find some option to get more confidence intervals rather than defaults. Okay, you need to try that. 80 and 95 we are getting by default. Any other question? I'll wait for another 2 minutes. Yeah, Arun, you get that latest code? This video record, the video recording we didn't get. I think you need to connect Swagato sir or Nivedita, I guess. Only. I'm not sure. Actually, it's not. The file is not with her, me.
Hello.
So you can connect Swagato sir. Okay, please upload the recording of last 2 days. If you are unable to find, just drop one email to Swagato sir or Nivedita. Yeah, best alpha or best weight. Yes, best alpha for exponential smoothing you need to find. Best weights for that one. Okay, one mistake was there. Mistake, not mistake. One you might get confused. So for period 3 only you need to do. So just do one thing. For WMA, I'm changing the requirement a little bit. For WMA, you see, for WMA, 3 weights are there. So period is only 3, 3, 3, 3, 3, 3. Only this string will suffice. Weight. Otherwise, you see, 1, 2, 3, 3, 2, 1, 2, 3, 1, 1, 3, 2, 3, 1, 2, 2, 1, 3. That's it. Do this only for this piece, because if you are changing the period, then your number of weights will get changed. Thanks for pointing that out. So you'll get confused then. You need to add more weights if the period is 4. So just do this only for period 3, and 6 kind of weight combination you can have. Okay, that's it for WMA. For loop, I cannot access the variable outside of loop. Can you teach global and local variable? Yes, we don't need this concept for this, Vipin. Believe me. For loop, so global and local variable, this is applicable only for functions. Okay, not for loops. For loops are always global. So I am writing this, whatever I am writing in this code, this is a global. This is global for the session. You can access anywhere. No function is there. So you just need to put a for loop over here and calculate the accuracy EMA, and you can keep on appending. Okay, and obviously we can have a discussion of local and global variable, definitely, but it's not contextual for this, relevant for this. So for loop, nothing to do with local and global variable, everything will be global. Okay, Vipin? Okay, I have doubts for function only. Okay, so function, yeah, for function it's relevant. We are not using function over here. If you want, you can. Yes, if you can, you can. Okay, then we can. So just try that out. We'll discuss within using function. Okay. Yeah, today is complete, Rupam. Yes, I am waiting for your doubts and all. Okay, thank you. Thanks for your time. Thank you, everyone. And study
Thank you, sir.
and try to. Yeah, thank you. I'm disconnecting then. Thank you.